Alright, so now we're going to take our vector knowledge and we're going to build it, and we're going to make it a little more real life, which just adds a few extra components to it. So if we think about what we have, we've got an airplane that's flying 500 miles per hour due south, so that's what that looks like. And he's also going to be flying with or into some jet stream or wind speed. So for this example, we've got a wind speed of 80 miles an hour in the northeast direction. So from here, from the end, I'm going to throw in a jet stream of 80 miles an hour. Northeast is going to create a 45-degree angle. That's equal parts north to equal parts east. Has a magnitude of 80. My airplane had a magnitude of 500. The resultant vector right there is going to be the actual path and actual magnitude of that airplane's path when he's flying with the wind or into the wind for this problem. So over here, we want to find the velocity of the airplane. That's A, velocity, A, airspeed, whatever we want to call it. Because it went straight down, there's no horizontal component. So you could write in there 0, I, 0, 180I, however you want to write it, but that's still going to give me no horizontal component. We went down, so it's a negative 500J. So we just went in the vertical direction. The wind speed, however, is going northeast, so we're going to use our little formula. We take the magnitude times cosine of the angle times I, plus the magnitude times sine of the angle, J. That's a J. And we can simplify that, so that gives me 40 radical 2I plus 40 radical 2J. So those are the separate vectors, the separate components. The velocity or the ground speed is going to be the airplane in addition to the wind. So it's the actual speed that he's flying at. That's going to be my resultant vector. So we're going to find the resultant by adding my two together. So we take the airplane plus we're going to take the wind speed. And then all we're doing is combining like terms. So we're going to put the i's together and the j's together. So we have 40 radical 2I, and then we're going to have 500, let's see, if we type this in, negative 500 plus 40 radical 2 gives me negative 443.43J. If we want to simplify the I guess I should have done that. It's going to be 56.57I minus 443.43J. So that would be the ground speed. If we want to find the magnitude, so we're going to take this new vector, and if you think about it as a picture form, if we are going 56 units in the I direction, negative 443 units in the J direction, that's the actual vector. And yes, that does match up. So sometimes it helps to draw this out. We've got 56.57, negative 443.43. We want to find the magnitude. Well, right triangle, Pythagorean, if you ever forgot. So we're going to take the square root of the I term squared and the J term squared, doesn't matter if it's negative, which is going to give me, let's see here, type this in, 447.02 miles per hour. So that's the actual speed that plane is going at when you factor in the wind. The direction, well, we need to find this angle, just like we were doing with the basic vectors, the direction angle. So it's a right triangle. We have the opposite and adjacent leg. So then inverse tangent of negative 443.43 over 56.57. When we type that in, we end up getting negative 82.73 degrees. And you can keep it that way, or you could subtract it from 360 and get 277.27 degrees if you want to go from 0 to 360.